Hello, 8th grade. Are you ready for some chemical reactions? This is the next chapter in our work in chemistry this semester. Probably the most important, probably the most applicable chapter in your preparation for high school chemistry. All right? So please redo these videos. There'll be another one after this next week when we talk about other things. But for now, this is intro to chemical reactions. And to start with, I'd like to do a little chemical reaction here. I have this clear, colorless liquid at the bottom of a Erlenmeyer flask. Erlenmeyer flasks have slanted sides. Beakers have straight sides, all right? And in this balloon, I have a white powdery substance that I'm going to dump into this clear liquid, and then we're going to see what happens. All right. Notice that I am wearing personal safety protection here, eyes and so forth, because in anything in chemistry you want to be safe. All right. So here we go. I am going to take this and we are going to see if we get a chemical reaction here. Got some fizzing, some foaming, we've got production of gas. Swirling things around. And by now, you're probably realizing, yeah, it's baking soda and vinegar. All right? But the point is, we didn't have this balloon filled up with stuff beforehand. And a question in chemistry would be, what's inside the balloon? Or what is this stuff now inside the flask? All right. Is it the same or is it different? And the answer is that it's different because of this thing called a chemical reaction, which is the basic idea that in a chemical reaction, a new substance or substances are formed. You start with something and you get something different. All right? New substances, different. When we say a substance is different, it is different chemically, which means it's bonded with other atoms in a different configuration, a different ratio, and it's different physically, the observable characteristics, right? This balloon was not all inflated when we started this, all right? That's an observable characteristic, all right? I've got no longer clear liquid here, but kind of a milky white liquid. We see physical characteristic production of bubbles, all right? And we see that the more I shake it, the more I smash it together, the more bubbles I get, all right? And we have new stuff being formed, which is the basic definition of a chemical reaction. All right? New stuff. So, in chemistry, we talk about two things in a chemical reaction. We have reactants and we have products. All right? Now, the reactants are the beginning substances. We had baking soda inside the balloon and we had vinegar outside the balloon. They were the reactants. They were the substances we started with, all right? And at the end of a chemical reaction, you have what are called products. Products are the resulting substance or substances you get at the end of a chemical reaction. And so this gas here is a product of the chemical reaction, all right? This stuff in the flask is no longer vinegar, it's something different, all right? And that makes it a product. Chemically different, physically different, and in fact, if you could feel this, it's colder. In other words, this reaction has also had an effect of absorbing heat. All right? Remember, there's no such thing as cold in science. There's just absorbing heat or giving off heat. And in this case, we say that this reaction absorbs heat, which makes it feel cold. All right? If you ever had to put a cold pack on your knee for whatever, you're creating a chemical reaction that absorbs heat and you feel cold, which is another sign of a chemical reaction occurring. All right? Now, in chemistry, we have what are called chemical equations. There are no equal signs in chemistry, all right? There are arrows, and the arrow is read as yields or produces. And on the blunt side of the arrow, you always have the reactant or reactants. And these reactant or reactants yield, produce some kind of a product, which is always at the pointy end of the arrow, all right? Because this arrow can go both ways, as we will see later on. So products are always at the pointy end. Reactants, which you start with, are always at the blunt end of this chemistry arrow, which is kind of sort of like an equal sign, but really isn't, all right? Don't think of this as an equation, all right? Even though this is written as a chemical equation, slightly different, all right? So in chemistry, reactants yield products, all right? Now, when we talk about introduction to chemical reactions, we can see how fast or how slow they go as one characteristic of a chemical reaction called the speed. And the speed of a chemical reaction depends on a number of things, like the temperature, all right? How hot or cold determines how fast or slow the molecules inside the reactants are moving, all right? The faster they move, the more they bump into each other, the better chance they have of bonding. Right? Surface area, all right? If you take a sugar cube and drop it into your iced tea, it takes a long time for that sugar cube to dissolve. But if you crush it up into a powder and put sugar powder into your iced tea, it's gone. Why? Because you have increased the surface area, allowing more contact between the iced tea and the sugar, all right? And finally, we get into something in chemical reactions called a catalyst, which is some substance that can change the speed of a chemical reaction, but not be part of the chemical reaction. It doesn't change in itself. And catalysts are really big in biology. A lot of what we get in our digestive system could not take place at the temperatures of our body unless there were catalysts called enzymes that help break apart food and things like that, and yet themselves are not part of the whole chemical reaction. They just speed up the chemical reaction or make it happen at a lower temperature, all right? So these things can alter the chemical reaction, all right? Now, how do you know there's a chemical reaction taking place? Well, you can see the production of a gas is a typical idea here, all right? In this case, the gas is carbon dioxide, all right? And if I were to release this balloon and let it float into the classroom, I would be contributing to global warming by releasing carbon dioxide into the atmosphere, all right? We can look for changes in color. Sometimes you play around with two clear chemicals and they become bright blue or red, signifying that there has been a change in the electron configuration that reflect or absorb light. You have the release or absorption of energy, all right? In this case, this is absorbing energy. This liquid is now much cooler than it was when we started off, all right? However, there's also chemical reactions that release heat, all right? We'll get into those later, all right? If it absorbs energy, we call it endothermic. And if it releases heat, it's exothermic, all right? This happens to be an endothermic reaction. We have a new physical characteristics that happen. We didn't have gas before, but we do now. That's a physical characteristic, all right? We have, it just looks different. The book talks about iron rusting and turning red when it combines with oxygen very, very slowly. That's a new physical characteristic. It's observable, all right? Or it has new chemical characteristics, all right? Eventually, I could keep dumping baking soda into this and it wouldn't react anymore because the chemistry inside is different, all right? Different chemistry. These are all evidence that, yes, a chemical reaction has occurred, all right? Now, in your book, you're going to get the intro to this just by reading pages 168 and 169, all right? But instead of doing stuff out of the book, I've got a POGIL for you. Yes. And this one I think you'll find quite interesting, as most of these POGILs are. It's about what are called limiting and excessive reactants. This is going to focus in on what's going to go into the chemical reaction, the reactants. For example, all right, if we say we have, we want to make some water, H2O, all right, your basic chemical formula, all right, a ratio here, 2 hydrogens to 1 oxygen, 3 atoms altogether, right? And we have 12 moles of hydrogen. Remember that a mole is 6.022 times 10 to the 23rd atoms. And it is also, each mole is also equivalent to the atomic mass of that element. So you know exactly what you're dealing with here. So I've got 12 moles of hydrogen and 12 moles of oxygen, an equal amount, all right? The question your POGIL is going to ask, and the way you do this, is how much water can you make? Can you make 24 moles of water? I don't think so. All right. Because you see H2O combines in a certain ratio. In fact, you need twice as much hydrogen than you do oxygen to make 1 molecule of water. And that's where this whole POGIL is getting at here, all right? In other words, we can't just make 12 moles of water here. You see that? Because I gotta have more hydrogen than I do oxygen. So we need 2 hydrogen moles for every 1 mole of oxygen. So there are 6 moles of 2 hydrogen, all right? If we take hydrogen and break it into groups of 2 that we're gonna need for each 1 molecule of water. That means I can have 6 of these groups, we'll call them moles, that's what chemistry uses moles for, it's our units. 6 moles of 2 hydrogen atoms, all right? So we can only make 6 moles of water because that's the amount of hydrogen we have. Yes, we have more oxygen, but that's left over. And that's the whole idea. Since hydrogen gets all used up and there's oxygen left over, we say that hydrogen is the limiting reactant here, all right? The amount of hydrogen limits the final product, how much water you can make, whereas oxygen is the excess reactant. That once we combine everything we can combine in the correct ratio, there's oxygen left over, and that's the excess reactant. And that's what this POGIL gets at here. And it starts you off in kind of a neat way by assembling race cars. Different parts that you need to make a race car. And like 4 tires and 1 engine. That's like chemistry. It's a ratio of what you need to make 1 molecule of something. And so it takes you from assembling cars to assembling molecules in a nice way that I hope will make a lot of sense to you. And that is your only assignment this week. Read the book, take some notes, get some notes from this, and then go to the POGIL. And I encourage you to get together with other people and do this POGIL together, all right? So that you can all turn it in with all your names on it, which would be good, all right? All right, then I will see you all next week.
Cute. Okay,